Okay, so let's get started. So in this class, we will finish up the group practice on the data analysis about the thermal process design. And if we have time, we will talk about the aseptic processing just to get started. Because you guys will start working on the lab report, which will be due by the end of next week. So I'm going to briefly go through the required sections in the lab report and what are the discussions need to be covered. And also I have posted a sample lab report for you guys, and please download it, or you can use it as a template. I think you guys have written a lot of lab reports in other classes. Um, I think the majority of those lab reports they share the similar format, but there might be a little tiny difference, such as citation style. Either you combine the results with the discussion together or separate them. Please follow the template in the Canvas, and let me know if you have any questions. Okay, so before we start, I want to share with you um, what was done typically to do the analysis if we are not teaching this course online. So this is the first time that I think this type of work is taught online, because normally in person or face-to-face class, we give students a sheet of this plot, or the blank scale, and just like the psychrometric chart. So we ask students to label those points on this graph, and you can see on the left side that there's a product temperature. Okay, on the right side, this is the difference between the retort temperature and the product temperature. So this is and you can see it's in log scale, and we ask students to mark all the points on those curves, and then calculate those parameters and plugging them into the equation. So the way that we are teaching is basically relying pretty much on Excel or sometimes other software. So it requires some proficiency in changing this graph, because plotting it in log scale and the reversed uh, order is sometimes takes some time to figure out. So this is great because working on the computer is always much more efficient using uh, uh, than those manually plotting. So I think that will have more long-term benefit by teaching it directly on the Excel. Okay, so before we start, I will want to quickly review that the 7 steps that we have been introducing last week about the calculation. So the first one is to plot this curve and write the governing equation, which all of us have done so, right? Um, and today we'll start with the step 2. The first thing is to measure the length of the heating rate constant, because there's a linear region in that heating curve. And after that, we'll calculate the thermoelectric factor. Basically, we take the extrapolate on the of those straight line and find its intersection with the y-axis, and find the readings, and we can use the equation posted in last class to calculate the thermoelectric factor. Basically, it tells you how long it takes for the heat to penetrate the can and the food product. And also we'll calculate IH, which is the temperature difference between the product temperature and the retort temperature. This is a static value. Okay, so last lecture, some of you are confused whether it's dynamic value or static value, and this is always the question. So this one is it's the simple one. That is the static value. It won't change. And step 5 is a little bit complicated, is to find the G value, because we have 3 steps involved in this step. Okay, and after finding G value, we'll determine the come-up time of the retort, and we'll have to look at the temperature sheet printed out by our retort system and figure out how long it takes for our retort um, to um, to increase the temperature. Okay, and finally, after we get all those parameters, we'll plug in all the parameters into the calculation. Okay. All right. So in last class, we used the data number 4407 from the first trial, right? And we already um, plotted out the curve like this, right? The green one, pretty much like the green one. And let me ask if does every group plotted out this curve already? If you have problems still stuck by um, with the plotting the curve, figuring out the time series, let me know. But otherwise, we'll try to move on to the next step. Okay, so I assume that every group was able to get this plot out, and we'll move on. But if you have questions still, like formatting the scale, changing the normal scale into log scale, you can send me a message while I send you guys in the breakout room, and I can join your group and do some troubleshooting. All right. So let's start with the group activity 2 here, to calculate the thermal lag factor and the heating constant rate. So as I showed you guys before, to calculate thermal lag factor, we will extrapolate this curve and find the intersection on the y-axis. And after reading those numbers on the y-axis, we will plug in those numbers and figure out the JH, which is the thermal lag factor value. And I'll combine this activity with measuring the length of heating rate constant, the FH value, okay? So I'll give you guys about 8 minutes this activity. And we can extend if the time is not enough. So I'm going to put you guys into 4 breakout rooms. Okay, and you guys, so I'm going to open those rooms. And you guys can select your group. 8 minutes, allow participants to choose room. Okay. All right, so all the rooms are open. If you have questions, send me a message and I'll join your group, okay? Sophie and Zoe, if you need me to put you to your group, please let me know. Time. So let me maybe show you a demo this time. So I think most of you know what is the concept of the FH value, right? So the FH is the heating rate constant. It's the time needed for the heat penetration curve to cover one log cycle. So that's a definition. Um, so when we talk about a one log cycle, it's on this time temperature difference curve, temperature difference scale, and we found this is 15 minutes because we within this 15 minutes, we can reduce the temperature difference from, for example, in this case, I picked the starting point here, somewhere here. So you can see if you move your point here, you can find that the starting point is 28 minutes of the processing, and the temperature was 57.85, right? And when we talk about one log reduction, it means that the y-axis will decrease to 5.78. So right now we need to find how long it takes for the temperature gap to decrease to 5.878. And you can find this point by moving around your mouse, because every time when you move to one spot of this curve, you'll get a reading from this curve. Let me zoom it in, right? So for example, here we know our initial point is which point did I pick? 5.8, right? Okay, let me pick this one. This one is more, because with the zoom in, it's more accurate. So 57.8. And now we need to find the 5.78. And if you go here, okay, so this was 28 minutes, 10 seconds. We have 57.8 degrees C. And now we need to find at which minute it drops to 5.78 C, because that's one log reduction, right? So it move here, 6.24, it's maybe not low enough, okay? And if we move up, okay, this one's close, 5.65 at 1 hour and 16 minutes, okay? 1 hour, 16 minutes, 5.565. 1 hour and how much minutes? 7, let me use, okay, 15, let me use 16 minutes. Oh, this one is exactly there. An hour and 15 minutes, 15 minutes. And 50 seconds, right? So at this time point, we have exactly one log reduction of the temperature. And once we get that, we can calculate the FH value, by subtracting the time difference, right? It'll be equal to 1 hour, 15 minutes, 50 seconds minus 28 minutes, 10 seconds. See how long it takes, right? So if we calculate that, I think it's somewhere between like 48 minutes also. It's just an approximate number, right? 57 to 58 minutes. So this is how we get the FH value. Can you guys understand that? Okay.
I think at least unsure about like how to plot that curve, like what values are you using?
Oh yes, how to plot out that curve. Okay, so let me show you step by step, okay? All right, so guys, this is our raw data, right? And you guys have all this the time series on the left side, and the y-axis we have temperature. So what I do is that I I copy pasted the time, the temperature starting from 9:58 because that's our starting temperature, right? Because we recorded how when we start running the retort, and that was 9:58. So we started at this temperature time, and the first thing that I told you to do is to reconstruct the time series. For example, we there are two ways you can do it. If you want to use 9:58 um, 40 seconds for the first data point, and 9:58 50 seconds for the second data point. That's one way of doing it. So in this case, if you plot this out, you will have um, exact time on the x-axis. Okay. So this is one way of doing it. So let me plot out this curve. Okay. So there are several ways you can plot it out. The first way is that you can start with a blank plot, and then you right click and to select the data. Okay. And in the legend, you can add one data curve. For example, you want to say probably this is the initial plot, and then y-axis you can use the exact time, and on the y-axis you can select the temperature, and then once you click OK, then you get this very small curve, and because you have all the time is in default is starting at 0 minutes, 00. So here you one thing you can do it is to you can probably reformat the scale. Okay, so let me see how to do that. So here, because you can choose how where we're starting with and where it ends up with. So here, the number here is not exactly reflecting the time because the Excel is not intelligent enough to recognize what it is. But if you change those numbers, for example, I change 0 to 0.1, and you'll see that it's kind of rescaling everything. You see, basically it changed its starting time, okay? Or, but everything is just not exactly as, because optimally, if you are using a more advanced software in the data analysis, they allow you to use the time format data to rescale it. But in Excel, they only recognize the digital data. So sometimes we have to guess where it starts from. For example, the maximum is 0.55. Here, probably you can put 0.3 or 0.4 to rescale it. If you point 0.3, I think we can expand this curve a little bit larger. Right, so start from 7:12 in the morning and ends up here. So this is the way that you can rescale it, one way. And the other way, let me move this somewhere else. Okay, and the other way of doing rescaling it is to use another time series, which is the retort time. Okay. So for example, here you can use 0, 0, 0 as your starting, and you can mark this as a time elapsed, which means how much time has passed since the retort. Okay, so this is time 0, and we have time. I mean, the system think this is the actual time, but in your understanding, you can understand it as the how much time has passed since you start retorting. So in this way, you might not need to rescale it, the curve anymore, because everything is um, the starting time is 0 automatically. So same thing, if you want to plot it out, we start with a blank plot and go to select data, add data series. Or you can say this is plot 2 and choose your X value and pick your Y values here. Okay. And in this time, you have a very nice um, plot with the time series that is narrowed down to the time range that you want. Okay, so there's a trick of doing this, but if you check every data point, the Excel thinks this is the absolute time. I think it's a morning in the but in our understanding, this is time elapsed. Okay, so this is a rescaling, and I guess many of you might have the problem about how to convert the scale into log scale and how to get the temperature difference. There are too much data here, and I might have to delete the curve because um, it's slowing down my computer. Well, then delete that, and delete that. Okay, so here let's look at how to plot out the curve in this way. So first we need to subtract the retort temperature by the product temperature, right? To get those values. And we know that our retort temperature is, zoom in here, retort temperature is 123 degrees C, right? So, and the product temperature at every single time point is showing on the Q volume, okay? And I'm going to plot out the temperature difference between, so the temperature difference will be equal to 123 minus the product temperature at different time spot, right? So this is how we calculate the y-axis, right? And here you can type in the equation, use equal 123 minus, for example, let's use the column Q as the product temperature, and you can get the temperature difference right here, and just drag it down all the way to the end. And then in this column, you'll get the temperature difference column, right? So now we can plot it out. Let me start with a blank curve. Start with blank curve. And then let's say this is temperature difference curve. Okay. And then we choose the x-axis, the time series, and we choose the y-axis, the temperature difference that we just calculated. So if you have any problem following any of the steps, let me know. I can re-explain. It might be easier, can save some time if I explain now than later, okay? All right, so now we get this curve. Probably many of you have seen this before. So now we have a reversed curve because normally the y-axis goes up instead of the values goes reverse way. But now we need to first we need to flip it over, and second we need to convert the same interval the interval from the same value into the log scale, right? So if you right click the axis. So first you select the y-axis and right-click format axis. Okay, and you'll see a panel about formatting the axis in the in the right side. So that I'm using the newest version of the Office. If you are using an older version, probably if you have problems seeing this panel, please let me know. I can help you to figure out, do some troubleshooting. So on the right panel, there are a few parameters you can choose. So the first one, the bound, basically you can select the region that you want to plot it out. So in our case, our y-axis start from 0 to 120. That's why I have minimum 0, the maximum 120. And units is the major is the, because they're smaller, so for each interval it's 20, right? And sometimes there are some minor units, but because in our case it's too small, we cannot see here. And if you move down, there's a logarithmic scale, which we can convert this interval into a log interval, okay? And if you click that, you'll see that it becomes 110, 100, and 1000. So that's log interval, okay? All right. And then after that, you'll see there's a value in reversed order, okay? And if you click that, everything will be flipped over. And then you'll see this very nice curve, just like how we plotted out in our class.
Oh yeah, so the log values are for both x and y axis, right?
No, actually, it's only for the y-axis because
Okay.
we selected y-axis to see if there's a small window here, and you can do so for the x-axis, but in this time we specifically are formatting the y-axis. Okay, and if you click the x-axis and select the format axis, in that case we will be formatting the x-axis.
Okay.
Okay, and if you see this curve, I guess you guys know how to do the FH value and the JH value, right? All right, so probably I will give you guys another 10 minutes and you guys can try to plot out this curve and do some calculation. And if you guys are not finished, I can probably, because we have to move on to the next topic, we have to finish this part by the end of this class. And I will just finish showing up my demo, and I will set up all the my office hours to do the troubleshooting with you this week. If you need any help, maybe yeah. I mean, it's difficult with the the remote way to do this way calculation. So I will put you guys into groups, and probably guys, one of you guys can share the screen and can work together and figure out how to get the number. And after 10 minutes, let's check the answer. And if you guys finish early, you guys can move on to do the following steps, because all the steps is in the slides.